So what we want to figure out now is, what is this bond worth? We are told that the first payment is in 3 months, and whenever we need to value some kind of contract, we ask two questions. The first is, what are the payments? So we've already drawn the payment stream. The second is, where am I standing? At which time am I asking this question? And here in the exercise, it tells us the first payment is in 3 months. And what does that mean? It means that if the first payment, for example, falls at the end of the first half year, then if the first payment is in 3 months, then we're standing 3 months into the year. So we're standing at time t equals a quarter if we consider t equals 1 to be the 1 year unit. So what is the bond worth at t equals a quarter? Well, what we want to find now, as we also talked about earlier, is v of 1/4. Now we can do that multiple ways. We can look at the payment stream and consider the present value at time 1/4 as either, we discount all of the future payments back to time 0 and accumulate 1/4 year, or we discount them back to time 1/2 and then discount another quarter year. All depends on how you like to think about this stuff. Well, the way I like to think about it is, I want to try to stand at time 1/2 and consider both this payment here and also all of the future payments discounted back to time 1/2. And then I want to discount all of the discounted payments from time 1/2, 1/4 year back to time 1/4. So what does that mean? Well, that means that the present value at time 1/4 is equal to the discount factor to the 1/4 power multiplied by the present value at time 1/2, including the payment at time 1/2. And we denote that normally by a minus, because normally when we consider the present value of future payments, when we consider that using v, we mean the future payments without the payment at the time we're standing at. But what we want to look at here is all of the payments, both at time 1/2 and all the future payments. So we denote that by a minus, which means that we are standing probably just a little bit before time 1/2. We also use this notation sometimes for the fairness criterion. Okay, so the bond's value at time 1/4 is equal to the bond's value just before time 1/2 discounted 1/4 year. That makes good enough sense. So what is the bond's value here? Well, first we have the payment of 20 at time now equals 1/2. And then we have the next payment at t equals 1, which is discounted 1/2 year. So that's 20 multiplied by the half year discount. And then we have the 20 that's paid here, which is discounted 2 years. So not 2 years, but 2 half years, sorry. So it's discounted a half year each time, and that's done 2 half years. And so on and so on and so on until we reach the last payment of 20, which has been discounted half yearly. How many times? Well, 1, 2, 3, 4, and so on, 19 times. And how do we know it's 19 and not 20? Well, we can kind of figure it out in the sense that the payment that falls at the end of year 1, which is essentially 2 halves, well, that's discounted once. And the third payment that falls is discounted twice. So the 20th payment and last payment that falls is discounted 19 times if we do half yearly discounting. And then last but not least, we also have the 1,000 sized payment, which is also discounted 19 times per half year. So it is 1,000 multiplied by v to the 1/2 to the 19. And we take all of this at this time point and then discount it another quarter year using v to the 1/4. So let us just write this sum up a bit nicer. So we can take the 20 out of a lot of these expressions, out of a lot of these terms, and then what we have is v to the k v to the 1/2, that's our half-yearly discount factor, to the k, where k goes from 0, 1, 2, and so on up to 19. So k is equal to 0, 1, 2, 3, 4, and so on up to 19. So that was these terms here. Now let's also write in this term. This term is just plus 1,000 multiplied by v to the 19/2. And we take all of this and discount the quarter year. So we're almost done. Now we just need to evaluate the value of this sum. And what's the value of this sum? Well, it is a geometric sum. So we can use our geometric sum formula from chapter 1 in the book that tells us that whenever I have sum a to the k and I sum it for k going from 0 up to n minus 1, then this is equal to 1 minus a to the n divided by 1 minus a. So in this case, I apply it for my a, which is equal to v to the 1/2. And when I do that and use the formula, I can see that the above is equal to 20 multiplied by 1 minus v to the 1/2 to the 20th power divided by 1 minus v to the 1/2 plus 1,000 multiplied by v to the 19/2. Take all this and multiply by v to the quarter. And probably the last part that we can do here is to notice that, well, we can multiply v to the 1/4 into the parenthesis, but it's kind of superfluous in a way, so we don't really need to do that. A thing that we can just rewrite inside the parenthesis is essentially we'll have 20 multiplied by 1 minus v to the 10th divided by 1 minus v to the 1/2, and then plus 1,000 multiplied by v to the 19/2, as so, and then we have v to the 1/4. So we will use v equal to 1 over 1.03 to calculate the numerical value of this expression. And that in Excel, so let me see and try if I can find this. So oops, let's see if this works out. So we have the interest here and we have the discount factor here. So this is the annual discount factor. And then here, maybe I should change this. So I want 1 minus the discount factor to the 10th divided by 1 minus the discount factor to the 1/2. And then I have 20 multiplied by this fraction. So what I have here is essentially this thing here. And then over here I have, well, this is very slightly wrong. I want 1,000 multiplied by v to the 19/2. So it's v to the 19/2 as such. And then I want to, it's because I was playing around with some formulas before this. So what I want now is the sum of these two. So the sum of the first term plus the second term multiplied by the discount factor for the quarter year, so v to the 0.25. What to do? My answer is 1,095.9, or just rounded 1,096. And that's also Eustein's answer, so that makes me very happy. So I hope that you guys got the main points of this exercise. One of the main points is that, no, we'll take that in the next video.